Go. Hello and welcome to another chemistry session. Today we'll be looking at a very essential and basic principle in chemistry called the particle theory of matter. So this theory covers how particles are behaving in all three states of matter, or the three basic states of matter. So this theory says that matter, that's solid, liquid, and gas, is made up of very small particles, so small that they are invisible, which means you cannot see it with your naked eye. But there are particles in all the three states of matter. We are only focusing on the three states of matter, but all states of matter are made up of very small particles. So that's the first thing that the theory of particle theory mentions. But the particle theory also mentions the fact that these particles are always moving. That is right, they are always moving. You might be able to say, okay, I understand that in gases they are moving, and probably in liquids the particles are moving. But how is it that the particles are moving in solids? So to better explain all of this, we are going to look at a simulation, and we are going to see how particles behave in the three states of matter. And remember, all three states are made up of particles, small particles that cannot be seen. And in all three states of matter, these particles are moving. Alright, so let's go into the simulation. Right, so here is your simulation. On your screen you can see a setup, a scientific setup, and this is brought to us by fet.colorado.edu. Yes, fetcolorado.edu. It's a simulation, science simulation on the states of matter. So this is a chamber in which we would have whatever gas or liquid or solid that we're testing, and this is our heat source. We can apply heat to it. I'll be posting the link to this simulation so that you can test it for yourselves and get a better understanding and an appreciation of what is happening in this experiment. This is our thermometer, which measures the temperature, of course, and it will show you the change in temperature as we apply heat to this chamber. So this is our list of molecules and atoms. Now atoms are the basic particles that we can have in any substance, and molecules would be a combination of different atoms or sometimes the same atoms. For example, in oxygen, you normally have two oxygen atoms attached to each other that forms the oxygen molecule. In water, you will see one oxygen molecule and two hydrogen molecules attached together to form a water molecule. So atoms are the basic particles, while molecules are a combination of the same or different types of atoms. Alright, so let us look at what happens now in different states of matter and how they behave. Let's start with solid, and we're using water molecule. So we see in a solid, if you should be able to see in a cube of ice under a microscope, this is what it would look like. We see that the molecules are moving, they are vibrating. They aren't able to move freely, but they are still able to vibrate. So according to the particle theory of matter, even in solids there is movement. So we see movement taking place between the solids. Now you can pause this video and think about it. Think of how you would describe the movement. So go ahead, pause the video and think of how you would describe this movement. Now that you have thought about it, we can say that, for example, this movement is restricted. There is vibration, but the vibration is not that strong, and the molecules are not able to move freely, so they are vibrating kind of like in the same space. So this would be like you're seated in your classroom, you're moving in your desk, you're moving your arms, you're moving your legs, probably tapping your finger on the desk. You're moving, but you're not moving out of space. So you're still vibrating, but you're still in the same space. So think of the vibration and the movement of particles in a solid as if a person is seated at a desk and they are moving their body, but they are not getting up out of their space. So the movement is limited. You can only move in a small area. That is because the particles are very close together, as you can see. So the particles are close, so the vibration and movement is restricted. Let us look now at how water molecules would behave in a liquid state. So we can see that in a liquid state, they are moving much freer and they have more space between them. So because of the space and the attraction between the molecules is not so strong as in a solid, because in the solid the force of attraction is very strong and they aren't able to move freely. In the liquid, however, the force of attraction is not as strong as in the solid, so the particles have more space to move and they move more freely, and the vibration is even stronger than in a solid. So although in the solid they are moving, in the liquid they are moving a bit more freely and the vibration is stronger and there's more space between the particles, as you would have already learned from the basics of the study on the spaces between particles in different states of matter. Now this is how it looks in a liquid. So if we should change this to gas, we see a different picture. We see that the particles are, the space is so big that I can move the mouse around and almost not touch any of these. The space is much bigger, wider in a gaseous form. So we see that the vibration is all over the place. So in a liquid, they might be moving like they are in the same classroom. They have a bit more space, but they are still restricted. In a gas now, the particles are moving as if the person is outside in the schoolyard and they are running all over the place. They have all the space that they need to move about. So the vibration is much more rapid and the space between them is much larger. So pause this video again and think of how you would describe the difference between the space, the space, 2, the vibration of the particles in solid, liquid, and gas. So now that you have thought about it, you can say that in solids, according to the particle theory of matter, in solids the space between the particles is smaller and the bond of attraction is much stronger, so the vibration is less. Vibration is restricted to a small space. In liquids, let's go back to the liquids. In liquids, the space between them is a bit larger. The force of attraction is weaker, so the particles vibrate much stronger than in a solid. While in gases, the force of attraction is very weak, so the particles are free to vibrate rapidly and they move a lot because the space between them is larger and the force of attraction is smaller. So you might be wondering now, what would make the difference between these? Because water, as we learned in the last session, can exist in all 3 states, solid, liquid, and gas. So what would cause the difference between the way in which the particles behave? Now think about it. What is different about water when it's in all 3 stages? What's the difference that would cause the particles to be so far apart or so close together, or vibrate a lot versus not vibrating very much? If you thought about energy, you are correct. So the amount of energy between the particles increases as it changes from solid to liquid and then to gas. So solids have less energy, hence motion is much slower, much weaker, less vibration. Liquids have a little bit more energy, and so they are able to vibrate more. And gases, of all the three states that we mentioned, gases have the most energy. So just to recap, according to the particle theory of matter, particles are in every state of matter, solid, liquids, and gases. These particles are very small, they are invisible. So all three states have invisible particles. That's the first thing. And also, the particles are always moving. They move differently depending on the state of matter, but the particles are always moving. Again, according to the particle theory of matter, all three states of matter have invisible particles, and these particles are moving. So, that is it for how particles behave in different states of matter. That is the particle theory of matter. Thank you for watching.